All right, so number 4, it says if f of x equals the integral from 2 to x of the square root of t cubed minus 1 dt, then f prime of 2 equals what? Okay, so it's asking for f prime. So if I was taking the derivative, so f prime, I do d dx in the front of it, right? So how do I take the derivative of this integral? Yeah, all you do is just plug in the x, right? So f prime of x is going to be the square root of x cubed minus 1. So that means f prime of 2, you just plug in 2. 2 cubed minus 1 is 7, right? 8 minus 1. So it's the square root of 7. So 4 should be the square root of 7. All right, number 5, you have f of x equals the integral from 3x to the square root of pi, which is a number, of cosine of t squared dt. All right, you might want to rewrite this as negative square root of pi to 3x. That's usually how we looked at it in class, right? So now I know when I take the derivative of both sides, this 3x is just going to go in for t. But then what do we need to multiply by? 3, right? The derivative of 3x. Okay, so it's going to be negative cosine of 3x squared times 3. So you end up with negative 3 cosine of 9x squared. Do you guys see where the negative came from? So the negative was from switching this around. Okay, the next one uses the table. So it says use the table above to compute the left-hand Riemann sum. Okay, most of you guys still need to sketch this out, which is fine. You can sketch it out if needed. But basically, if you're thinking of your left-hand rectangles, that means you're using the left point. So you'd go over like that, over like that. You know what I'm saying? So the points that you're going to use are x equals 1, 1.75, 2, and 2.5. You're not going to use 3. You're using the left. Now think about what each of those rectangles would look like. So the height of each one uses f of x. Okay, so your different heights are going to be 4, 12, 6, and 12. But are the widths all the same? No, the width for the first one is 0.75. Oops, I'm trying to write it in there. The width for the second one is 0.25. The width for the third one is 0.5. Do you guys see where I'm getting these? So it's just the distance between the x values. And the width for the last one is 0.5. Okay, so basically what you have is 0.75 times 4 plus 0.25 times 12 plus 0.5 times 6 plus 0.5 times 12. Okay, and when you work that all out, you should get, what did I say? 15, so B.
How come you want to use the first 4 rather than?
Because it's the left hand. See how it says left hand? So you want to think about your rectangles. If I had drawn my curve, you would use the left point, right? Like that. Those would be left rectangles. Okay. So number 7, it says use the table above to compute the integral from 1 to 3 of f prime of x dx. Okay, when I first looked at this one, I was like, oh wait, they didn't tell me what to use for my approximation, like left hand, right hand, midpoint. But then I was like, oh, this is an exact answer. Think about it. How do you integrate? So how do you integrate f prime of x? You get capital F of x, right? And it's going to go from 1 to 3. So all this is just f of 3 minus f of 1. That's the exact answer. So f of 3 is 2, f of 1 is 4, so 2 minus 4 is negative 2. So negative 2 should be your answer. Okay, the next one. So it says g of x equals the integral from 0 to 2x of f of t dt. Use the table to compute g prime of 3. So again, this is using that fundamental theorem of calculus. If I was finding g prime of x, I'm taking the derivative of both sides. So that means I'm going to have just plugging in the 2x for the t, so f of 2x, but then what do I need to multiply by? 2, right? The derivative of 2x. Okay, so that means g prime of 3 is going to be f of 2 times 3 times 2. So f of 6 is 7. times 2, so you get 14. All right, and number 9, I told you there was a typo. This should say f double prime of 1. So I have capital F of x, so if I'm finding f prime, you just take the derivative. So you're going to take that x, you're going to plug it in. So you get 1 over x cubed plus 1. It's like you're multiplying by 1, right, the derivative of x. All right, how about f double prime? What do we do? Quotient rule, right? Low d high minus high d low all over the square of what's below. So you end up with negative 3x squared over x cubed plus 1 quantity squared. So if I'm finding f double prime of 1, just plug in 1, so I get negative 3 over 1 cubed plus 1, so 2 squared, so 4. So negative 3/4 A. Okay, and the last one you guys had to do, so the midpoint Riemann sum. Okay, this one I still had to kind of sketch out. So if you guys sketched it out, that's fine. You're between 1 and 9. And you have y equals x squared, so some kind of parabola. And you want 4 intervals. So it's nice when you have 4 because you just have it and have each piece. So have it. So what's between 1 and 9? Directly. Not 4.5. 5, right? See how that's 4 units? This is 4 units. You could add them together, divide by 2. Okay, what's between 1 and 5? 3 and 7. All right, but these aren't the points you're going to use because these are creating the 4 rectangles. And with those 4 rectangles, you're going to use the midpoint. So you're going to basically have, in the middle, you're going to go straight across. Okay, so think about what x values are directly in the middle. We'd have 2, 4, 6, and 8 directly in the middle. Now the width of these rectangles is always the same. It's always 2. So you can pull the 2 out. So that's the width of each one. The heights, do you guys know how to find the heights? Yeah, it's just x squared, right? So it's just going to be 2 squared plus 4 squared plus 6 squared plus 8 squared. Okay, and I went ahead, and I was stupid, and I went ahead and found this answer. And then I looked at my answer choices, and I was like, oh, well, I just did a lot of work because it's already set up for you, right? This is in the form 2 times 4 plus 16 plus 36 plus 64, so it's C. So here's your answer. So always look at your answer choices. All right, you feeling better about those? Yeah, did you at least get half of them right?
Yes.
Okay, good. All right, so let's try some free response questions. Do you guys want a second to look at them before we talk about them? Yeah, so work with the person next to you and kind of talk through it first. See if you can get it, and then we'll go over them. All right, so part A, what'd you guys do?
I found the rate 2 times to beat the average of 5.
That's exactly what you need to do. Good. So when you read it, it says, use the data in the table to approximate the rate. So when you guys see rate, you should be thinking of slope or derivative, right? Rate is slope or derivative. It also tells you the units, entries per hour. And you knew that the values of ET was in hundreds of entries. So how do you get entries per hour then? So you'd have to do some kind of divide by time, right? So for A, you're going to have to do E of 7 minus E of 5 all over 7 minus 5. You can't do the derivative because you don't have any function to take the derivative of. So this is a slope question. Okay, now you could have used other things. You could have used 2 and 8, but it makes more sense to use the ones that are directly next to 6, right? So E of 7 minus E of 5. So I'm going to have 21 minus 13 over 2. So 4. And then always write your units. So what are my units for this one? Hundreds of entries per hour, right? So you could write 400 entries per hour, or you could write 4 hundreds of entries per hour, which is kind of weird. Okay. B. So using a trapezoidal sum with 4 subintervals given by the table to approximate the value of 1/8 of 0 to 8 e t dt. Okay, so 4 subintervals. Do you guys see what's creating the trapezoids, or do you need to sketch it out?
How do you have
Sketch. Okay. Okay, so you have 0, 0, 2, 4. 5, 13. I'm gonna run out of room. 7, 21. Oops. Mine's just gonna be flat across because I ran out of room. 7 and 8. Okay, so the key to trapezoidal, whenever you see trapezoidal on your AP test, know that they're probably not going to use the same width for each trapezoid, right? Or height. Okay, so our first trapezoid is not a trapezoid at all. It's a triangle. Because the height, like one of the B1s, I guess, the B1, B2, was 0. Okay, now the next trapezoid is right here. So remember, they're on their sides. Okay, so the first one is just going to be 1/2 base times height. So it's going to be 1/2, 2 times 4. That's the triangle. Okay, the next one's going to be 1/2. Do you guys remember the formula for a trapezoid area? Yeah, it's 1/2 h times b1 plus b2. And h is this horizontal distance. The distance between the two parallel sides. All right, so in this case, our h is 3 for the green one. b1 is 4. b2 is 13. So now are you seeing how you could have just pulled this information from the table? Because you're using 0, then 4 and 13, then you're going to use 13 and 21, then 21 and 23. Makes sense? I guess the first one used those two. Okay, so the next one. So the next one's going to be 1/2. Now the distance between them is only 2, right? Distance between 5 and 7. And those heights were 13 and 21. Okay, and then the last one is 1/2. Now the distance between those two is just 1, between 7 and 8. And then your numbers are 21 and 23. You get 85.5. Okay, so using correct units. So what are my units here? Yeah, it's weird because E of t is hundreds of entries. That looks weird. Hundreds of entries. And then your time is, I mean, this bottom thing is hours, right? So your units are hundreds of entry times hours, which is weird. Okay, so, oh, but then you do the 1/8, don't you? I forgot my 1/8 out front. Okay, what do you guys think the 1/8 is? So we need to multiply by 1/8. Anybody have any ideas what that's doing? Oh, man. My calculator's dying. Okay, what'd you get when you divided by 8? 10.688. All right, so look at this setup right here. Does that remind you of any formulas we learned? I know it's like way tiny on my screen. Does it remind you of anything we learned in class? No, nothing? You've forgotten first semester completely? The distance, you were going from 0 to 8, right? Your interval was going from 0 to 8, and now we're multiplying by 1/8. In other words, 1 over b minus a. So what was the formula where you had 1 over b minus a times the integral from a to b of f of t dt? What was that called? Close. Average value. So average value of f, right? So in our case, f is, our function is our e of t. So we have found the average value of e of t.
What is that? Like, what is it?
It's telling you the average height of your curve.
Okay.
So in other words, for ours, it's telling us the average number of entries during that time period, right? So that's what you need to write. So there would be, remember this is in hundreds of entries, so there's approximately 1069. So 1069, see how I just moved it over twice for hundreds of entries. Is the average number of entries in the first 8 hours. Does that make sense? Okay, that's what you're finding. Yeah, so that 1/8 was getting rid of our hours unit. Okay. Okay, so C. So at 8 p.m., volunteers began to process the entries. They processed the entries at a rate modeled by the function p, where p of t equals t cubed minus 30t squared plus 298t minus 976, hundreds of entries per hour between 8 and 12 hours. So they started at 8 p.m. So according to the model, how many entries had not yet been processed by midnight? So t equals 12. Okay, did you guys think about that one? Do you want a second to think about it? No? All right, discuss with your partner. All right, so Mackenzie asked a good question. She said, are they still entering for this contest from 8 to 12? No, they've stopped entering. Like, they only submitted tickets between 0 and 8. Okay, and then between 8 and midnight, they are processing the tickets. They're counting them. Yeah. All right, so it says, so let's see. So how many entries had not yet been processed by midnight? So anybody have any ideas what we do? Yes.
Plug 4, because there's 4 hours that they're working on it into the function they gave.
Not quite.
What'd she say?
Plug 4 into it because it's 4 hours. Yeah, Grant?
If you plug in 12 and 8, you subtract the p of 12.
Close. Yeah, Rachel?
11 plugged in 12 and then subtracted the total. From 23, yeah.
Okay, so kind of. You're close when you're plugging in 12 and 8. I like that.
Multiply by 4 then after.
But what are you plugging it into? So this is the rate. What?
Does he integrate it?
You have to integrate, right?
No!
Because this is the rate,
Dang it.
right? So look for your
Wait,
keywords.
is it the derivative, so you have to find the anti? Because it's the rate which is slope?
Yeah, this is saying the rate, right? This is the rate that they're processing things. So if you actually want to find the number of entries, you need to integrate. So you need to find how many they processed from 8 to midnight. And you're going to integrate. I believe this would probably be a calculator one. Okay, and then what are you subtracting it from? We already found this number. This number right here, 85.5. That's our approximation for the number of entries that they had from 0 to 8, from noon to, was it noon? Yeah. Yeah. The 10.688 you can, but remember that's the average number during the 8 hours. So if you wanted to find the total number, you need to multiply by 8, right? So it takes you back to the 85.5. Oops. Okay. So let's integrate. So do your math 9. Pause. 60 exactly? Okay, so you have 85.5 minus 60. Oops.
16.
16, okay.
Yeah.
Okay, so you get 69.5. Now this is in hundreds of entries. So this is,
There's like half numbers in there.
Or maybe.
right? Did you guys get this? All right. D. Oops. So D, according to the model from part C, at what time were the entries being processed most quickly? So what do I need to find?
Maximum rate of change.
Right, the maximum rate of change. Well, how do you find the maximum rate? Find the derivative of the rate and set it equal to 0, right? Makes sense? You're maximizing the rate. If you're maximizing a function, you'd find the derivative of the function and set it equal to 0. If you're maximizing the rate, then you find the derivative of the rate and set it equal to 0. All right, so the derivative of the rate, p prime of t, is going to be 3t squared minus 60t plus 298. All right, set it equal to 0. So I just put this into your calculator and find the intercept. So graph it, find where it crosses the axis. It's probably going to be between 0 and 12, I would guess, right? I got t equals 9.184. Did you guys get that? No? What'd you guys get? Okay, so I wrote around 9:11 p.m. How did I get 11?
We got
You had 10 exactly?
Yeah.
Oh, so maybe I messed something up.
I had 9.184.
so obviously something else. But I did like the minimum and I did left and right and then
We just did 0.
Oh, yeah, you just need to find the 0. Find where it's equal to 0, right? Where the derivative's equal to 0. Okay, how did I get 9:11? So how did I know 9:11 p.m.? Sorry.
Divided by 60.
Yeah, I took 0.184 and I said, well, what part of the hour is that? So I multiplied by 60.
Oh my.
Make sense?
I don't want to lose your sentence.
Yeah, there's like an extra little number. All right, so scoring guide. So we'll talk about the scoring. So this was for part A. Shh, guys. B, C, and D. So A, you just got 1 point for the answer. It didn't say answer with units, probably because in part A they already told you what units you should have, right? But usually they'll give you a point for units. B, you got a point for getting the correct trapezoidal sum, for the actual approximation, and the meaning. So the approximation part is the 1/8 of that trapezoidal sum. Okay, and then the meaning, how we explained what it was. C, you got 1 point for setting up the integral correctly and 1 point for getting the correct answer. And D, you got 1 point for knowing that you had to do p prime of t equals 0. So even if you had just written that part, if you had just written, see, I didn't even write equals 0. I should have done that. But even if you had just written p prime of t equals 0, you get a point because you knew what you were supposed to do. Maybe you took the derivative incorrectly. Like what if I'd written 398 there? I wouldn't get that point then. So make sure you're writing p prime of t equals 0. So you get a point for that. You get a point for identifying candidates. So basically you got a point for knowing that it was the locations where you were crossing the axis. So you get a point for that. And then the last thing, you got a point for your answer with justification. So the answer here. Did it say justify? Ah, man, justify your answer. So you would also need to, how would you prove that that was the maximum and not the minimum? What did I leave off that I didn't get a point for? Yeah, but they don't grade the chart, right? So you could draw the chart, but then you need to explain the chart. So you need to say, since it was decreasing and then, so since it was positive and then negative, I guess, not decreasing. So since P prime, when you graphed it, it was positive above the axis, then it was negative, right? That means that there had to be a maximum. When you go from positive slope to negative slope, there's a maximum there. Okay? Makes sense? Do you have time to start this one? Did you guys get out at exactly the hour? Is that right? Okay. So let's start this one. Okay, so the function g is defined and differentiable on the closed interval -7 to 5 and satisfies g of 0 equals 5. So notice this is the graph of g prime. Okay, it consists of a semicircle and 3 line segments as shown in the figure above. Find g of 3 and g of -2. All right, g of 3. Now, if I was given that g of 0 equals 5, and that's going to be important. That's kind of like an initial condition. All right, so let's think about g of 3. If I can relate it to 0, I'll be good. See how I can write like this? If I took the antiderivative, I'd get g of x, and I'd go from 0 to 3. So in other words, it's going to be g of 3 minus g of 0, which I know what g of 0 is. I know it's 5. How do I know what this is? Allie, what'd you say?
The slope.
Not the slope. It's the area, because this is the graph of g prime. So it's your area from 0 to 3. Right there. Which is a quarter of a circle plus a triangle. Okay, so I'm going to have a quarter of a circle, so 1/4 of pi r squared. So r is 2. So just pi plus 1/2 base times height, the triangle. Base is 1, height is 3. So I get 1.5 plus pi. That's equal to g of 3 minus, we know g of 0 is 5. Okay, so when they give you this initial condition, always think about your fundamental theorem of calculus, how you could use that. So add the 5 over, so you get 6.5 plus pi. All right, do you guys see how you could do g of -2? Same thing. Okay, making sense?
You go from -2 to 0 to
From -2 to 0, yes.